Alright. 7.1.9 direct variation. Before we begin, I want you to kind of get a preview of what we're going to be doing. So if you would please look at page 81. Right underneath the graph for speed of that car. They have it both in the XY chart and already graphed for you. What I want you to do is either look at the XY chart or the graph, and I want you to fill in step number 1. Fill in step number 1. Fill in those fractions. Alright. So 130 over 2 is equal to 195 over, go?
3.
Is equal to what over 4? Go.
260.
Got it? Okay, what is the constant rate per hour? All those ratios, when you put them into a unit rate, will be the same. What is that rate? Oh, hi Sam, I didn't even know you were here. Welcome back. Go. 65 miles per hour. So put that in step 2. Okay, the constant rate of change or slope of the line is the change over miles over the change in time. If you look at that, do you see how it's rise over run? It's y over x. Everyone notice that? Perfect. So it's telling you already that they subtracted and found 65 miles per hour in number 2. So that box should be 65 if you haven't written it there already. It says or 65 miles per hour. And then they want you to write a sentence that compares the constant rate of change and the constant ratio. Are the ratio and the rate of change the same? You'll get your answers for number 1 and number 2. Are the miles per hour the same? Go.
Yes.
Yes. Simple pimple? So when you're doing direct variation, you're looking for are the constant rate of change and my slope the same? If they are, then you have a direct variation. Let's go to page 80. I know, it's crazy. Let's go to page 82. Alright, in your textbook, everyone sees the key concept box?
Yeah.
Okay, someone read the words part for me. Sophie Karras. Read the words.
Linear relationship.
No.
Yeah.
When two variable quantities have a constant ratio.
Wait, where are you at?
What?
No. Inside the key concept box.
That's where you want.
Oh, yours says a linear relationship?
What does yours say?
A direct variation.
A direct variation.
A linear relationship is a direct variation.
Okay. Go ahead and read yours then, Sophie.
Which one?
The linear.
A linear relationship is a direct variation when the ratio of y to x is a constant. We say y varies directly with x.
We say y varies directly with x. We use the constant k just as a random variable. Okay, but when you see the word k, or not the word, the variable k, that means are they changing at a constant rate? Or do they have a direct variation, which is what we just talked about? Are the slope and the change in variation the same? So the symbols, you can either do y over x equals k, or y equals k times x. Both of them will give you the same answer, and then they give you an example, y equals 3x. That's a lot of information. We'll go through it in just a little bit. Okay? So let's look at example number 1, and it's easier than it looks from what you just read. Number 1, the height of the water as a pool is being filled is shown in the graph. Determine the rate in determine the rate in inches per minute. So look at those points that they've already graphed for you. You have, what do you have?
5.2.
5.2, 10.4, 15, 6, 28. What am I going to do immediately? Because I want to do unit rates. Think about last week when we did constants, or when we did slope. What has to go on top? What has to go on top? Think of rise over run. What has to go on top? The x-axis or the y-axis? Go. The y-axis. So do you see how they rewrote them with y over x?
Yes.
2 over 5, 4 over 10, 6 over 15. You have to be really careful that you write them as y over x. If you don't, you're not going to get the right answer. That might be something to write down in your student notebook on your student side. You have to write down your coordinate points y over x. You might remember that from Friday, but it would probably be helpful for you to write it again so you remember it again. Mr. Thomas.
Well, I was doing that, but in homework, I don't even know why they did this, but on 15, I answered D because it's y, which is 3 over 1. But in the back of the book, it says it's C, 1 over 3.
So number 15?
Yeah.
Dot S is what? Actually, we wouldn't do dot S because that's a little bit in the middle and it's going to give us some weird numbers. What dot would you use?
Dot R.
Dot R. So what coordinate is dot R?
-6.
-6.
What do you mean? Feet?
It's got to have 2 coordinates.
What? Oh. What? -6, 0?
-6, 0. How are you going to write that?
Well, you would put in, there's one of those, whatever, the parentheses.
Good.
And then there's a minus sign, then there's a 6. Then there's a comma, then there's a 0, and then there's another parentheses.
Okay, so how do you get from R to S? What would be your rise?
You would go up 3 because 6
Good.
-6, and then you would go over 5.
Nope.
No? Why not?
Because you're starting at -6.
Yeah.
What's the distance from -6 to 3?
6. Because if you add
-6 to 3. -6 to 0 is how many spaces?
6,
0 to 3 is how many spaces?
3,
So 6 plus 3 is?
9.
So then you have 3 over 9.
Uh-huh.
Reduce that.
1 over 3.
Right.
Oh,
Does that make sense?
yeah.
Okay. Good question. Very good question. Okay. So then they did the work for you on number 1. Do you see how they all are the same? They all equal what as the unit rate? Griffin.
They all equal 0.4.
Good. 0.4 what? Charlie.
Inches.
Per?
Minute.
Inches per minute. Is that a direct variation? Yes. Why is it a direct variation? Because they're all the same. Okay. So it's pretty easy. See what they're doing? Number.
Can they ever not be the same? Like,
We're going to find out.
really?
We're going to find out. Letter A. I will tell you that there is a direct variation. Let's read it. 2 minutes after a diver enters the water, he has ascended 52 feet. What do you need to know from that sentence? Not Michael.
What?
Thank you. Max.
That After 2 minutes, he descended 52 feet, and then after 5 minutes, he descended 130 feet.
After 5 minutes, what'd you say?
130 feet.
130. Okay. Where is my rise? Is it going to be 5 and 2, or is it going to be 30 and 50, or 130 and 52? Which one is going to be my rise, and how do you know? Which one will be my rise? Max, we'll just keep going since it's...
Wait, wouldn't you use negative coordinates because you're going down?
Well, you could. You don't really need to.
Okay.
You can do absolute value and say that the distance is is an absolute.
The y-axis would be the feet, and then the x-axis would be minutes.
Okay, so if you're saying, though, say that one more time.
The y-axis would be the feet, the x-axis would be the minutes.
And how did you figure that out? You're correct.
Because if you put it into a sentence, it's 52 feet.
Very good. You see what he did? He put it into a sentence. Okay. So, how am I going to write my fractions to figure out what the direct variation is, Aiden? I always want to do what over what?
In that you do 2 over, 52 over 5.
No, 52 over
2.
Good.
But then, since it's...
Hold on. And then this one would be?
130 over 2.
Not over 2, 130 over 5. Okay?
You wrote 5 underneath both of them. That's why I got kind of confused.
Okay. Thank you.
Then
So I want everybody to reduce them in your work zone. Reduce those two fractions.
I did.
Okay, hold on. Let them reduce it. Write those fractions down in your work zone. Reduce them both, please.
What's your work zone? Oh, I never use that.
Michael, raise your hand, please. Bless you.
Thank you.
You're welcome.
Thank you for saying that.
Anytime. That needs to go away. Thank you. Alright, both fractions. Go down to unit rate of, Will?
26 over 1.
In words.
26 feet per
26 feet per
minute.
minute. Everyone see how we got that?
Yeah.
Okay, now, let's troubleshoot this. Let's say you don't know which one is X and which one is Y. Does it make any sense to say that he descended 1 foot in 26 minutes?
No.
I mean, you can, but on that story problem, does that make any sense? No. So that's how you can troubleshoot it. You can go, that doesn't make sense. He wouldn't have gone 1 feet in 26 minutes. Those distances are way too far for you to just go 1 foot. So you can go to yourself, oh, hold on, that's not right. Let me flip them upside down. Okay? I do want you to get in the habit of knowing which one is X and which one is Y. But if you do get an answer like that and you're like, hold on a second, that does not make any sense, then that's when you're going to go, okay, hold on a second. I need to redo this. Okay, does that make sense?
Yeah.
Okay. So let's look at that other equation that we have for example number 2. And you might want to put this in your notebook. This is something new. So when we were going through the description of direct variation, one of the formulas that we use is y equals kx. Okay. Many of you know that our English language came from Latin and Greek, and in Latin and Greek, the C sounds like a what?
K.
a k. That's where we got the word, or the variable k from. So when you see the word k, k is the constant. K is the constant. Okay, how long is your math class on Mondays and Tuesdays? It's always
45
an
minutes.
hour. An hour. Is that constant?
Yes.
Yes. So K would be that number. How many innings are in a baseball game that doesn't go into extra innings?
7.
Major league. 9. Is that a constant if we say no extra innings? Yes. Okay. So when you see the word or the variable k, that means constant, because constant, that's where they got the a from. Figured I would spin a little English in there. Okay. So let's look at number 2. The equation y equals 10x represents the amount of money y that Julio earns for x hours of work. What does that mean to you? That number is x hours of work. What would the 10 be? If we're figuring out money, what would the 10 be? You want to think of a constant. What is a constant when you get paid? You can even think of Coloradoville and El Salverte Ciudad if you want to. What's the constant, Megan Fabro?
Being paid on the same day, the same amount of money.
Same amount of money. So to you, what does that 10 mean? It could be $10 per day. It could be $10 per hour. It could be $10 per second. That would be a fun job. $10 per week. But it's constant. It's a constant. Now let's look back at that problem. Does it tell us how often he gets that money? Someone help me out. Does it tell you how often he gets paid? Mo. Every hour. Sorry, I don't know why I keep saying it like that. I keep going, because I want to say Mora and then I stop and go mo. Did you hear Mora though? It says in your story problem, X every hour. So that means, when I write this out, he gets paid $10 every hour. Is that direct variation? Yes, he gets paid the same amount of money every single hour. It doesn't fluctuate. All right. Now, if he gets a raise, or if they knock his pay because he's a bad worker, that's different. But I cannot warn you anymore. But when you I don't even know what to say now because I was interrupted.
By who?
It was direct variation, and when you
It's a direct variation because he gets paid the same amount of money every day. So I want you to look at letter B. What?
Can a number equal the variable k if it's not constant?
It shouldn't. We're going to get to that part in a second.
Okay.
Right now, these are questions that have direct variation. They just want you to figure out what number it is. So look at letter B. The distance y traveled by the Chang family in x hours is represented by the equation y equals 55x. You don't have to worry about y in these problems. Okay, y's just kind of hanging out there for you. So the Chang family travels y equals 55x. What does this mean in words? What does this mean in words? Griffin.
the Chang family travels 55 miles for unknown amount of hours.
Okay. So 55 miles an hour. Okay. Identify the constant of proportionality. So that means what is the x? Or what is the k? And I already kind of told you. Whoops. All right. That one's actually really easy because they already told you what k is. I think they gave you k. See how they replaced k with 55? That's your constant of proportionality. So he travels 55 miles per hour. Apparently they're driving on back roads and not on the freeway.
Yeah.
Michael.
So, is that the answer?
Mhm.
Well, like, there's nothing to do.
You just have to know what K is. As long as you know K is going to be your answer, that's all you got to know. It is kind of easy. Now we're going to get a little bit more tough. Okay? Determine direct variation on page 83. Not all situations with a constant rate of change are proportional. Likewise, not all linear functions are direct relations. So remember I said they both have to have a constant rate and they have to have a slope? You have to have both. You can't have one or the other and have a direct variation. So let's take a look at the pizzas. Pizza cost $8 each plus a $3 delivery charge. Show the cost of 1, 2, 3, and 4 pizzas. Is there a direct variation? Okay, you're all smart cookies. What part of that story problem automatically rings a bell to you that this is not proportional? Everyone should have seen this. What clues you in immediately that this is not proportional? Natalie? Good. It's only $3 one time, not $3 per pizza. You should already have known this is not going to be a direct variation. Yes? Yeah. So anytime where there's a one-time charge or let's say you go to, I know this was a question way back, you might not even remember it, but there was a question about you go to camp and you have to pay a fee and then you get paid, or you have to pay a fee for every day you're there. So you have to pay the fee to apply or whatever it was, and then you pay extra for every day you stay. That wasn't proportional. I think that was in algebra. Okay? But that's where this comes from. You want to figure out if it's a direct variation or not. So what I want you to do before we do anything is I want you to look at that chart. Everyone see it? Okay. Is it a straight line?
Yes.
It sure is. But what is not happening? What is not happening? Cheyenne.
It's not going through the origin.
It didn't go through the origin. So that's another clue. This is not going to be proportional because it didn't go through the origin. All right? Yes.
Now I know the answer is that it's not. But if you bought zero pizzas, wouldn't it still be $0? Because no one would have to give you $3 to deliver no pizzas.
Yeah, but look at the graph. That's why they gave you the graph. It doesn't go through 0, 0.
I'm saying, why wouldn't it go through 0, 0? Because
Okay, okay. That's a good question. You can even draw on this. Plot 0, 0. And then draw a straight line through all 5 points. Can you?
Yes.
You really try. Yeah.
Can you draw a straight line from 0, 0 all the way up to 435?
I did it.
Nope. So then that would be what? No straight line.
Okay.
Good question.
Where did they get 0, 4? I was paid $4 for nothing.
Where are they getting 0, 4 from?
See, the first. Yeah.
Because they're lining up their 4 points and making a slope.
I see.
I mean, you're not really going to pay $4 for no pizzas, but
They charge you for not buying.
that shows you that it's not proportional. Okay? If you're absolutely stuck and you're like, I can't tell from the story problem and I can't tell from the graph if this is going to have a direct variation, what is your final check that will give you the answer immediately? Julia Gill. If I don't know from the graph and from the story problem, what is the first thing I should do?
You should try and find rate.
Good. Find unit rates. Is 11 over 1 and 19 over 2, are they equivalent? They are.
Well, if you find
What's 11? Well, a little. What's 11 times 2?
so that's 22.
22. So it's not 22 over 2. It's
So it's
19 over 2. So are they equivalent unit rates? No. So that's another clue that it's not proportional. Okay? Okay?
No.
What?
Shouldn't it start at 3 and not 4 because the charge is $3?
They're lining up their points. The straight line they have, that's where it would go.
So, wait, what? Why would, so they're just putting a dot on 4 to make the line straight.
Mhm.
You can do that.
They want us to make, they are trying, yeah, that's a slope. But it doesn't go through 0, 0, so it's not proportional. I mean, if you get confused by it, put 0, 0 in your graph and graph it. If you can't do a straight line with 0, 0 in your other points, it's a no-go. Alright? Well, let's look at letter C. 2 pounds of cheese costs $8.40. Show the cost of 1, 2, 3, and 4 pounds of cheese. Is there a direct variation? Can you tell immediately from the problem?
Yeah.
Ellen, can you tell immediately if there's a direct variation? Yeah, is there? Yes. Why? Why?
Because 2 pounds costs $8.40, and there's no but if you buy this, it costs.
Okay, good. There's no extra charges or discounts or anything. All right.
Are you a germaphobe?
No, I just don't want your germs.
You just don't even
That's
Okay. Now, you do know it's proportional, and you do know it's a direct variation. Awesome. You're going to have to tell me what the direct variation is. So who wants to calculate the unit rate? Tell me what the fraction is first. Everybody should be doing this. What would your fraction be to figure out the unit rate? If it's $8.40 for 2 pounds of cheese, what are you going to write as your first fraction? Don't do a unit rate yet. Put that into a fraction immediately. Gabby, what would it be? No. Just with the story problem. It's $8.20 for 2 pounds of cheese. Write that as a fraction.
Oh, shoot.
$8.40 over 2. Yes? Okay, find me a unit rate, Gabby. Which in words would be $4.20. Good. $4.20 per pound. Okay? Everyone's going to answer this when I say go. If I don't know if it's proportional or not, I'm going to calculate all of the what? Go. Unit rates. How many do I need to do to be absolutely 100% positive? Go.
4.
3. 2 can kind of throw you off sometimes. 3 is a good number to stop at and go, yep, these are proportional. Yes. You have a sweatshirt on too. Yes.
I know, but he's cold.
It's going to get muggy. It's going to get muggy.
I'm down with that, but...
I'm not.
Okay, I was like, it's not open.
Number 4. Page 84.
What else do
Look at that XY chart. 1, 2, 3, 4, 12, 24, 36, 48. Does that have a direct variation? Everybody go.
Yes.
Do you see how easy this is? Wonderful. Will you please try numbers 1 and 2?